All right, let's talk about one of the biggest mix-ups in all of physics. It's a force you have felt literally thousands of times. That feeling that just pins you to your car door when you take a sharp turn. We are diving deep into the classic showdown, centripetal versus centrifugal force.
You know exactly what I'm talking about, right? You make a hard left and bam, you're slammed up against the right side door. It feels like something is physically shoving you outwards. But what if I told you that powerful outward push isn't a real force at all? The truth is a little weird, and it all depends on where you're standing.
To really get this, we've got to step out of the car for a minute. Imagine you're standing on the sidewalk, just watching the car go by. From this stationary point of view, what a physicist would call an inertial frame of reference, the picture becomes a lot clearer. And it all comes down to one key idea: inertia. Remember this from science class? Newton's first law? Basically, your body wants to keep doing whatever it's already doing. If it's moving in a straight line, it wants to keep moving in a straight line. It's lazy. It resists any change in direction. This one concept is the absolute key to this whole thing. Okay, so think about it. The car starts to turn, but your body, because of inertia, just tries to keep going straight. So what happens? The car actually turns into you. That feeling of being pushed out, that's not an outward force. It's the car door pushing inward on you, forcing your body to change direction along with the car. So that very real physical inward push, well, that's got a name. That is the force that makes anything and everything move in a circle. Meet the centripetal force. The name literally means center-seeking, and that tells you everything you need to know. It's not a result of turning, it's the cause of the turn. If you don't have a centripetal force, you don't have a turn, period. The object just keeps going in a straight line forever, just like inertia wants it to. Now, here's a super important point. Centripetal force isn't some new magical kind of force. It's more like a job title. It's a role that other, more familiar forces can take on. For the moon orbiting the Earth, gravity is doing the job of centripetal force. When you swing a ball on a string, it's the tension in the string. For your car to turn at all, it's the friction between the tires and the road. It's always a real physical thing pulling inward. Okay, so from the sidewalk, it's all pretty clear. But that doesn't explain why it feels the way it does. To get that, we have to jump back inside the car and look at things from the passenger's point of view. So now you're sitting in your seat. The world outside is whipping by, but inside the car, you're perfectly still, right? You're not moving relative to your seat or the dashboard. But because the car is accelerating, remember, changing direction is a form of acceleration, you're now in what we call a non-inertial frame of reference. And in this frame, the regular rules of physics start to feel a little wonky. So here's the puzzle from inside the car. You feel a very real push from the door on your side. Inward. According to Newton, if there's an unbalanced force on you, you should accelerate. So, why aren't you sliding across the seat toward the driver? Well, to make sense of this, you have to kind of invent a force. From your perspective in the car, you say, well, the only reason I'm not moving toward the center is because there must be an equal and opposite force pushing me outward, keeping me in place. And that imaginary, invented outward push, that's the centrifugal force. It's not a real physical interaction. It's a fictitious force that's really just the feeling of your own inertia trying to go straight. So we've got a real inward force and a perceived outward force. Let's put them side by side and make this crystal clear. This chart just lays it all out. Centripetal force, it's a real force caused by a physical interaction, like friction or gravity. It pulls inward, and it's what you see from a stationary or inertial frame of reference. Most importantly, it's the cause of the turn. Centrifugal force, it's a fictitious force. Its origin is just your own inertia. It feels like it's pushing outward, and it only exists in a rotating, non-inertial frame. It's not the cause. It's a perceived effect of the turn. And this is the single most important thing to remember. This is not a tug of war. It's not two different forces fighting each other. It is one event, just described from two completely different and equally valid points of view. And trust me, this isn't just some abstract physics puzzle. Understanding this difference is absolutely fundamental to how we build and engineer things in the real world. Let's look at a few examples. Take a centrifuge in a medical lab. It's way easier to think about it from the point of view of the spinning test tube. From inside that tube, there's a powerful centrifugal force throwing everything outward.
The heavier stuff, like red blood cells, gets thrown harder and faster to the bottom, separating it from the lighter plasma. It's a perfect example of using that fictitious force as a practical tool. Now think about a roller coaster loop. Here, it's all about the real, inward, centripetal force that the track is exerting on you. At the bottom of the loop, the track has to push up extra hard to both counteract gravity and make you turn upwards. That's why you feel so heavy. But at the very top, gravity is actually helping pull you down towards the center, so the track doesn't have to push on you as much, and you feel light as a feather, or even weightless. And maybe the coolest example of all, artificial gravity in space. You spin a space station, and the outer wall is constantly pushing the astronauts inward. That's the centripetal force. But for the astronauts living inside, that constant inward push on the soles of their feet feels exactly like an outward force pinning them to the floor. It's a centrifugal force that perfectly mimics the feeling of gravity.
So let's just nail this down one last time. From the outside looking in, a real inward centripetal force is what causes an object to turn. But from the inside looking out, a perceived outward centrifugal force is what explains why you feel stable and pressed against the door. Same event, two different but very useful descriptions. And that really makes you think, doesn't it? If a force that feels this real can just be a matter of perspective, it makes you wonder, what other things in our daily lives, maybe things that seem like unchangeable forces, are really just a matter of the frame of reference we're choosing to look at them from?